So I'm going to quick say that again for the video's sake. Some vocabulary, monomial is the same word as the word term, the way we've been using the word term. And so the way I want you to define it here is a single term, which is only multiplication or division. She drew a 3.
I drew a 3.
That's a big one.
Yeah, she was
Got it on video.
I'm going to keep this for like I did 3.
Maddie.
All right, and then polynomial is multiple monomials, so connected with addition or subtraction, multiple monomials. You can think of it as multiple terms as well.
Missed you. Can she hit you again?
No.
Oh. She missed you.
She hit me right in the arm.
She hit the
That
board.
was a heavy ball.
Oh, God.
All right, so over here in this first example, we're simplifying polynomials now. And so our goal with simplifying polynomials is to break down every polynomial because each term should be simplified before you can start to combine similar terms. If you think back to the color experiment at the beginning of the year, that's combining similar terms. And so let's first break down these monomials. And if you guys remember from last chapter, these are all exponent rules. And so for this first one, we have 2x squared y over x in the parentheses, and that's all put to a power. And so I would like you guys to start in the parentheses when simplifying terms. What are we simplifying here? How is that simplified?
You subtract the 1x on the bottom from the x to the second up on top.
Subtract the
So
exponents.
2x, y, x.
2xy, and then you're going to put that to the second power. And then just what's the next thing that we do with the exponent on the outside of the parentheses?
Either like distribute, kind of, it to the other terms.
Yep, distribute it to every single item on the inside, whether number or variable, and you're going to distribute it to their exponents. And so you'll do 2 to the second as you normally would. Then you do x to the second and y to the second. The rule is that you multiply the exponents, but since none of these have exponents currently, 2 just stays there. 4x squared y squared. All right, good job. Now this next term, we are multiplying. This is all multiplication. The parentheses there are just breaking it down into 2 different, I guess, it really isn't doing anything. It's just saying 3 times x times y squared times 2 times x. So how do we simplify that? Hannah? So you do the numbers, 3 times 2. And then you have the 2 x's, which means x squared, because they're multiplying. And then the y squared, or the 2y's. Is that all the way simplified?
Nope.
Ellen says yes.
Yes.
What do you think?
Yes.
Is Ellen always right?
Yes.
Last one, 4xy squared to the third. Look inside the parentheses. Can we simplify inside the parentheses? 4xy squared. Cannot simplify on the inside, so what do? Distribute the exponents. So 4 to the third, x to the third, and then y squared to the third, which is you multiply the exponents. And so 4 to the third is going to 64.
60.
X to the third, and then y, 2 times 3?
6.
6. Good. Now we have simplified all of the monomials, so we can look to combine similar terms. And I'm going to circle the terms as they exist so far. We have a positive 4x squared y squared, a positive 6x squared y squared, and a positive 64 x to the third y to the 6. When combining similar terms, let's go back to the color experiment. When combining similar terms, we combine terms that have the exact same combination of variables. The exact same combination of variables. with the color experiment, each variable was a color, and as you put it into the cup, it didn't change the amount of the cup, it only changed the color of the cup. And so each of these the variables, x squared, y squared has a certain color, x squared, y squared has the same color as that one, x to the third, y to the sixth has a different color. So if we combine similar colors, what are we combining? Yes, 4 plus 6. If these are the same color, x squared, y squared gives us a certain color, and so we combine them.
74.
And that gives us, this is plus, so 4 plus 6 is 10. X squared, y squared.
Plus 64 is 70. Oh, 74.
That is your final answer. Multiplication has certain characteristics where you can combine exponents. Addition and subtraction, though, do not share those characteristics. And if you were to put numbers in for x squared and y squared, and you were to add these two things together, you would find that putting the numbers in and then adding them would give you the same thing as this. Given more time and the ability to think on my feet, I would tell you exactly why that's true. But for now, remember, and my way of teaching this was through the color experiment, remember that variables change the color of the term, numbers describe an amount, and so when finding similar terms, you're finding similar variables and then adding the numbers, which is like the number of cups. Alright. This one is unique because it has distributing in it. Like the distributive property. Not distributing exponents, but the distributive property. And when we see the distributive property, or when we see parentheses, for now, we're going to split that, we're just going to say that's a term. We're not going to split it into two terms because of that addition sign. We're going to say for now that we're going to make it its own term. We're going to deal with it on its own. And so let's start simplifying these three different things. Starting with the first, we have 4x to the third, y to the fifth over top of 2x, y to the third. Where do we start? Hannah. So 4 over 2, simplify that. You can simplify it as a fraction. It would be 2 over 1, or just 2. X to the third over x is going to give you x squared. And then y to the fifth over y to the third will give you y squared. This one is distributing. And if you remember distributing, you take the number or the term that's multiplying with the parentheses, and you give it to each term on the inside. So the 3, positive 3 multiplies with the xy and with the x squared. 3 times xy. 3xy. And then 3 times x squared.
3x2 or 3x?
Yep, just 3 times x squared. And now we have two different terms here because we got rid of the parentheses. And so if we want to draw the squiggly line down now, we can. And then this last one is 4xy. There's no simplifying involved. And so at the bottom, remembering the sign that's in front of each one, we make our polynomial by adding or subtracting each of these terms. This is a positive 2x squared, y squared, positive, so plus 3xy, positive plus 3x squared, and then plus 4xy. So 3xy and 4xy have the exact same combination of x's and y's. And so you can add them together to create 7xy. Can 2x squared y squared combine with anything?
No.
Nothing. No other term here has x squared y squared. That's the only one with x squared, y squared. And then 3x squared is the only one with x squared. Alone. X squared alone. So this one has an x squared, but it's not alone. For this one, it is by itself. So that is your final answer